The Soyuz is a Russian spacecraft that can fit a crew of 3 on board. The Soyuz rocket is launched from the Baikonur Cosmodrome in Kazakhstan. On our globe, let's come over here to look at Europe and Asia. This is Russia. It's the largest country in the world. Mission control is in Moscow, Russia. The launch actually takes place right below, in the country of Kazakhstan. So why does Russia launch from a different country? When the Baikonur Cosmodrome was first built in the 1950s, these two countries were part of the Soviet Union. The launch site has been in use ever since then. The other reason has to deal with a little bit of physics. Let me explain. The best place to launch a rocket is right along the equator. Anywhere along here, the Earth is spinning at about 1,670 kilometers per hour. This means that a rocket launching to the east gets a free speed boost. You still get that speed boost when you are further away from the equator, it's just not as much. If you look at where Russia is, it's not very close to the equator. This is part of the reason why they still launch out of Kazakhstan. The rocket gets a little more of a speed boost. The Soyuz rocket is about 50 meters tall. The Soyuz spacecraft is hidden inside at the very top. This covering is called the launch shroud. This whole rocket is assembled just a few kilometers away from the launch pad. First, we start with the Soyuz spacecraft inside building 254. There are lots of tests to make sure it works correctly here on the ground. Then the Soyuz spacecraft is turned on its side and loaded into the launch shroud. Remember, this is the part of the rocket at the very top. This is all transported next door to building 112. This is where the Soyuz rocket is assembled in the horizontal position. The rocket is then transported to the launch site on a small train. This process is called the rollout, and it happens 2 or 3 days before the launch. The train moves slow enough that you could walk right next to it. It takes only a few hours to reach the launch pad. There are red protective coverings inside of each rocket engine. These will be removed shortly before the liftoff. The rocket and the train will slowly pull up right up next to the launch pad. Then the next step is to lift the Soyuz rocket up into the vertical position. 4 support trusses grab hold of the rocket to secure it in place. Then the 2 umbilical towers to supply power and fuel. And then the service towers, which rotate right up next to the side of the rocket. You can see how it has several levels to access different parts of the rocket while on the launch pad. Just for comparison, NASA in the United States builds rockets vertically and then transports them to the launch pad on a large crawler transporter. 2 different ways of doing things, but they both work. Let's talk more about the Soyuz rocket. It's powered by kerosene and liquid oxygen. Here's a view of where the tanks are inside of the rocket. It takes up most of the space. This is a 3-stage rocket. The first stage is made up of 4 side boosters and the central block. The second stage is made up of just the central block, and the third stage is the smaller block right above it. We'll see this in action in just a few minutes. Most of the rocket engines are on the bottom. The larger engines are fixed in place. They don't move at all. But the smaller ones, these are called vernier engines. They can rotate to steer the rocket. There's 2 on each side booster, and then 4 on the central block. Okay, so we have the first stage, second stage, third stage, the launch shroud with the Soyuz spacecraft inside, and at the very top is the launch escape tower. If anything goes wrong on the launch pad, it will lift part of the launch shroud and the top 2 modules of the spacecraft away from the launch pad. The stabilizing grid fins deploy, and then there's also more rocket engines in the launch shroud to lift it even higher. Then the descent module will separate and the crew can parachute safely back down to Earth. On most missions, the launch escape tower isn't needed. However, it has saved the lives of the crew on more than one occasion. About 5 hours before the launch, the tanks begin to fill with fuel and oxidizer. The 3 crew members will arrive at the launch pad in a bus. They will be wearing Sokol spacesuits. These protect the crew during the launch and other important parts of the mission. In their left hand, they are each holding a portable cooling unit. This will be used up until the moment they enter the Soyuz spacecraft. One last picture is usually taken here on these steps. An elevator then takes them up to the top where they can get into the Soyuz spacecraft. There is a hatch in the side of the launch shroud. This leads to the orbital module and then down into the descent module, of course being very careful not to damage anything. They are in their seats about 2 hours before the launch. In the center seat is the commander. This will always be a Russian cosmonaut. The other 2 seats are for the flight engineers. These may also be Russian cosmonauts or an astronaut from another country. The instrument panel is up here. Not all of the controls can be reached by hand. The commander in the center seat will have a stick to be able to reach all of them. The crew will hang a 0G indicator that's usually a stuffed animal or a toy. This is a nice visual reminder once they are in space and the effects of gravity are gone. Everything done inside of the Soyuz spacecraft is in Russian, which means all crew members must speak the language fluently. During the 2 hours before launch, there are many checks that need to happen to make sure that the rocket and spacecraft are ready for the launch. For some of that time, they will play music inside of the spacecraft to help relax the crew. 30 minutes before the launch, the service structure arms will be rotated away from the rocket. 15 minutes before the launch, all personnel are evacuated from the launch pad. At 35 seconds before the launch, the first umbilical tower is released. Then at 15 seconds, the second umbilical tower is released. At the moment of liftoff, the 4 support trusses rotate away and the Soyuz begins to rise. The Soyuz launch is automated, but the crew must be ready in case anything goes wrong. About 20 seconds after liftoff, it'll start pitching over to the side. At 2 minutes after liftoff, the launch escape tower will be jettisoned because it's no longer needed. The 4 side boosters now have empty fuel tanks, which means the first rocket stage is now complete. When the side boosters fall down, this is considered the Korolev cross. You can usually still see this from the ground. The central block of the rocket continues to fire on its own. As they continue to accelerate, the crew will feel as much as 3.5 Gs, or 3.5 times as heavy as they do on Earth. The launch shroud protected the spacecraft through the atmosphere, but were high enough up that it's no longer needed. At 2.5 minutes, it falls away, exposing the Soyuz spacecraft. This is the first time that the crew will be able to see outside their windows into space. At 5 minutes, the second stage is almost done. Before it finishes, the third stage starts firing while the second stage is still attached. This is so that the rocket is always accelerating, which will press the fuel to the back of the tank where it's needed. Then the second stage is jettisoned. The orange panels protecting the engines also fall away. Just before 9 minutes, the third stage cuts off. This is called main engine cutoff, or MECO. Shortly after, it separates from the spacecraft. The Soyuz spacecraft is now on its own. Inside the Soyuz, the 0G indicator will begin to float, and the crew members will feel weightless for the first time. Now the antennas deploy, and also the solar panels. This generates power for the Soyuz spacecraft. They are at a height of about 240 kilometers and traveling at a speed of 27,000 kilometers per hour. Nowadays, all Soyuz spacecraft are sent to the International Space Station, or ISS. The next step is rendezvous and docking. That means the Soyuz has to catch up with and then dock to the ISS. At the end of the Soyuz mission, the crew will have spent about 6 months on board the ISS. It's time for the astronauts and cosmonauts to come home. It only takes about 3.5 hours to get back to the surface on Earth. The Soyuz crew will be saying their goodbyes to those that will be staying on the ISS. Then they will enter the Soyuz spacecraft and close all of the hatches and get into their seats. Then they will release the hard dock latches and then detach from the ISS. This is called undocking. The spacecraft will slowly float away. Once they get to a safe distance, the Soyuz thrusters can be used again. The target landing site is back in Kazakhstan. Half an orbit away, on the other side of the Earth, they'll do what's called a deorbit burn. The main engine is fired for about 4 minutes and 30 seconds. Notice how the Soyuz is pointed backwards. This slows the Soyuz down so its path will now re-enter the Earth's atmosphere. This is like the Hohmann transfer that they used to reach the ISS. But this time, instead of raising the orbit, now we're lowering the orbit. About 30 minutes after the deorbit burn, the Soyuz turns 90 degrees, and all 3 modules are separated by explosive bolts. The reason they turn 90 degrees is to ensure that each module has a separate path down to Earth. That way there's no chance they'll crash into each other. The service module and the orbital module will go on to burn up in the atmosphere. In fact, for this reason, the orbital module is usually filled with trash. The descent module has a heat shield on the bottom. This will protect the crew from the fiery descent. As the atmosphere gets thicker, it will slow down the descent module. This part is called re-entry. Small thrusters are used to help steer the module through the atmosphere. The crew goes from feeling weightless in space to all of a sudden having several times the force of gravity pressing them into their seats. This can be very hard on their bodies. During this time, they have what's called a radio blackout, where the fire and heat prevent any radio signals from coming through. The Soyuz descent module will touch down on land. This is different from the splashdown that NASA has done here in the United States. The Soyuz is also built so that in the event of a water landing, it will still float. At a height of about 10 kilometers, it's time to eject the parachute cover. This is a series of 4 parachutes. There are 2 pilot parachutes, a drogue parachute, and then the main parachute. The drogue parachute slows the capsule down enough so that we can safely open the main parachute. There's also a backup parachute in case the main one doesn't work. The heat shield is then jettisoned from the bottom of the descent module. This exposes several soft landing thrusters, which will help cushion the moment of impact. To also help with this, the seats will rise up on shock absorbers. These will help soften the impact even more. The soft landing thrusters are fired about a meter above the ground. This is why you see all of the dust come up. It's quite a jolt when they finally touch down. The parachutes are then disconnected to avoid the wind from dragging the capsule along the ground. The astronauts and cosmonauts will need some help to get out of the descent module. The recovery crew is usually close by and ready to welcome them home.